went and harassed the BioConda people for a while, and then I also, then moved on to Conda Forge. But I haven't actually kept up with it that much in recent years, so I'm waiting for you guys to tell me all about what's happening in these bots and what you guys can make the bots do.
Oh my God, thank you so much. I'm so excited that you can be here as a nerd specialist in this. I'm just a user of Conda Forge. I have no idea about all of the nitty gritty. But before we get going, let's learn about the team that keeps science functioning, at least for the Python folks these days. CJ, can you tell us a little bit about yourself?
Sure. I'm CJ. I'm a software engineer at Lab 49. And let's see, I've been working with Conda Forge maybe since 2017, 2018. And I was one of the original authors of the AutoTick bot.
Excellent. Welcome. Marius, would you like to tell us a little bit about yourself, and welcome?
Hi, I'm Marius van Niekerk. I'm a software engineer at Flatiron Health. I've been involved in the Conda ecosystem for probably around 6, maybe 7 years now. Initially, I got involved back in my ad tech days, building and packaging out a lot of the sort of the Hadoop integration, Python tooling for Conda.
Well, excellent. I guess last and certainly not least is Mr. Becker. Could you tell us a little bit about yourself, please?
Yeah, my name's Matt. I'm Matt Becker. I'm a cosmologist at Argonne National Lab. So in my day job, I study the universe as a whole. And then I work on Conda Forge, other times of the day, doing lots of different things. I got started in Conda basically because everybody in cosmology and astrophysics uses Conda primarily. And that's where I first got exposure, and I've just slowly been dragged into it more and more as I got more interested.
That is very cool that your job title is Universe as a Whole. That is very neat. I think that should be in your LinkedIn byline right there.
It's not exactly that, but it's close enough.
No, got to go for the cool titles. That's really what matters.
We practically have superheroes on these streams. It's amazing. So thank you for telling us a little bit about how you got into the packaging stuff, Matt. How about you, Marius? Why did you get dragged kicking and screaming into this also, or what's your motivation here?
So my initial motivation was I just needed stuff to work, and so back when I started with Conda was sort of before wheels and things like that were in the state where they're now, where they're generally fairly good. But that was the state where I would like the same pandas built the same way on a cluster of Hadoop machines, and that was just virtually impossible back in 2013 or so. And so when Conda came around and it that solved that entire problem, I was like, oh, it's this stuff is cool. I should take note and start making use of it aggressively. And so I've been doing so ever since. And now I'm doing the same with reproducible healthcare data science.
That's awesome, man. I feel like you're in a better place than you were. I remember you as the guy who did Spark, and I'm just that man there is a sadist. But it's.
I'm still doing a little bit of Spark. That hasn't gone away. It's now just mostly more in the sort of Python/R numerical stack and less in the Java stack.
Nice. Well, hey, CJ, I guess it's your turn now. Tell us why you're in here. What pain are you fixing?
Yeah, I got involved the way that most people did. I wrote a package. All right, I needed a package to be distributed somehow. And I was like, Conda Forge looks interesting. Let's do that. And then as I kind of got frustrated with various pieces, I just kept automating them, and that just kept happening.
Sounds like an addiction.
Yeah.
Well,
I think a lot of us came initially for it's I need my 3 or 4 packages that I care about to exist, and then we stayed because like on working on Conda Forge, you get to work on a higher sort of like meta level of packaging, whereas like you get to it's like a lot of us have sort of got into this point where we no longer think of individual packages. We think of like moving large portions of an ecosystem, like sort of 500 or 1,000 packages at once, kind of thing. Which is like a very interesting space to sort of operate in.
Very
I was
cool.
about to say, is it more the metadata or is it the dependency tree that gets you and keeps you there? Because, once you have one package you need to install, then you have to keep on going down that ladder and find them all. It's not like whack-a-mole.
Yeah, and that's sort of the thing where it's like we think it's like I've gotten to the point where I think much more of like it's like packaging as a large like asynchronous graph traversal problem than anything else. Mm-hmm.
But for Matt, this is just a small part of the universe.
Yeah.
No.
I mean,
Wait, you'll find out that the underpinnings of the universe is a graph somewhere.
Yeah. I mean, it's the part of the universe that's maybe not just metals.
well, yeah. I mean, most of it's hydrogen and helium, but that's besides the point.
Oh man, I can tell that this is going to be a really good discussion that we're going to have. So let's kind of start moving into the main part here. But like before I get going, I need to talk about some vindication that I got like 2 years ago. And this has nothing to do with me, but I'm totally divvying things up. When Project Jupiter won the ACM award, I'm like, oh, okay, yeah, say something bad about notebooks now. It was very validating. And I'm just like, who from Conda Forge is getting one of these big awards? Is it the bots or is it the people or is it both? So I really wanted to find out about this. Like the scale that you guys are building stuff and the infrastructure that you're building has become like so critical. And it seems so large that I think it would be really nice to get some kind of perspective on how you all manage this, because this doesn't seem like mere humans can achieve it. So yeah, I don't know. Jillian, you're here with me today. Maybe you can help get us started and some questions that might be piquing your interest to get going.
Yeah, I want to know. So, how much time are you guys all able to devote to Conda Forge? Do you all have jobs that like really give you a lot of time to work on open source, or is this something that you do in your very precious spare time, or how exactly does that work? How did you get involved with this?
So sure. Let's see. So I certainly work on this on my spare time. Lab 49's been really gracious about letting me work on Conda Forge things and other like open source stuff as well. But it definitely changes day to day or week to week depending on what my obligations are. We're a consulting shop, so when I'm working with clients, I'm working on those things. But Lab 49 has been very nice about this.
That's awesome. How about you, Matt?
Yeah, so mostly nights and weekends. One of the things that's been going on, and this is true in all fields of science, but it's definitely happening more in cosmology, is that a lot of the main sort of software stacks and pipelines that people care about are essentially being distributed through Conda Forge, and that is the primary distribution channel. And at least some of my job, some of the time, is to help people maintain that distribution and ship it. So I actually get a little bit of time at work, depending on the context, to do a little work on Conda Forge, making packages, making sure the bot runs, but mostly it's nights and weekends.
Is there any way we can like ship you dinners and stuff like that to keep you working? What you need some support outside of this?
You need to be bribed with baskets.
Yeah, Marius, what about yourself?
So like some of these like it's like I tend to actually like do a reasonable bit of my Conda Forge work like as sort of like part of my day job. I don't do that much of it anymore, but like still a fair bit. My employer is also like it's like, yeah, it's like we hired you because you're sort of plugged into this like open source ecosystem and you kind of know what's going on there. So it's in our and your best interest to remain connected with that ecosystem. And so and it's like we also internally use Conda Forge for doing a lot of our sort of deployments and things like that. So making sure that that ecosystem remains healthy and stable is of tactical importance.
I find that to be such like an interesting part of open source these days that I think, and and just science in general, is that you really need to be plugged into these communities to be able to get things done, which is such a shift that I saw from, like 10 years ago when people were very protective of their SVM models in MATLAB. And there's just been like such this huge shift. And I wonder, how much is it going to keep going? Have you guys found that as well?
I've seen it in spaces. I think that's there's still this sort of there's still certain fields that particularly as some of these things become sort of more expensive and costly to do. So you're always still going to have your proprietary magical sort of click model that serves ads or whatever. But it turns out most of these industries tend to just all run the same stuff. And it's there's generally sort of an open secret of everybody's basically running the same things, but nobody publishes, particularly from the industry side. So it's sort of everybody is running the same things, but nobody's talking about it, which is still kind of weird. I think in sciences it's a little bit better than in industry. I'd hope.
Yeah, I've found that it's mostly young people in science that really push it. So enterprising grad students and postdocs who, take part of their time to publish their software and to move it onto Conda Forge and to build things like in my own field, like AstroPi, things like that really move the needle on pushing open source into the mainstream for science.
Very cool. Well, so we're here specifically talking about the bots today because I feel like they do a lot of work. But I also am hearing that you all do a lot of work on them. So let's kind of get into those things. And I was thinking, from what I've heard, there's 3 bots. If we miss one, we can talk about it later. But I figure we can go in order, and one of y'all just tell us about the bot, one of the bots. And I think the one I heard so far is the auto tick bot. And who's responsible for that one?
I mean, we nominally all are, since we're actually all on the subcommittee.
Well, who's responsible for talking about it and advocating for your bot?
I'd say CJ.
Oh, right.
Fair enough.
He unleashed it, so
Yeah,
he gets about it.
It's his Frankenstein.
Yeah,
its existence is my fault. I'll accept that. It's okay. So the bot, with the formal name of the Regrow CF AutoTick bot, which I think everyone can understand why it got truncated. Pretty much, it started out as a way for me to not have to put version bump PRs into all of my packages. So when I started working with Conda Forge, I put up a bunch of packages, and Conda Forge was still pretty young at the time. And so I ended up owning a bunch of dependencies. Somehow I'm the sole maintainer of the Conda Forge package for font tools. I'm not exactly certain why, but I needed it for something. But I'm personally, I'm not connected to the font tools kind of release cycle. And so I got very annoyed, every time I'd have to actually go and read font tools or even my own code to see whether or not a new version came out. And so I was like, this seems like a job for a bot. I'm literally telling one machine, I released a new version, and then I personally have to go tell another machine, hey, by the way, I released a version. There should just be a machine in the middle that mediates all this. And so I think in December, I wrote an issue that was really long issue. And then we actually started putting it into practice. And I think it first started up on Valentine's Day, the weekend before we had kind of cobbled some stuff together. Yeah. Me and an undergrad, Justin Calamari, that I was working with at Columbia, and it started cranking through things and started issuing version bumps. And so kind of dragged Conda Forge much more up to date, because we were running into issues where we had a lot of packages that were pretty far out of date. And then so that was kind of one half of the bot. And the other half of the bot are these migrations that Marius was talking about, where we move entire ecosystems. That started up that summer, which I think was the summer of 2018. And we pretty much had to rebuild every package on CondaForge. We decided to move Python versions, R versions, and GCC versions to an incompatible GCC.
Yeah.
So
okay, wait. We gotta unpack this a little bit. So like, how many packages and how much like were we abusing the bots to get this stuff done? You know, like were there like Wallies and like mini Wallies running around, or is it all one bot?
So it's one bot. I believe that migration was 4,500 packages, something like that.
Yeah.
So like it was large, and it ran for about 7 months.
Yeah.
Okay.
Largely because the process still has a human in the loop. So the way that we sort of orchestrated this thing is like, we've got a bot. It does some. It goes and looks at the recipes that underlie these Conda packages that we build, and it says like, okay, I need to change them in this way, and then it goes and changes them, and it changes them in the same way that a human does. It makes a pull request, and so that pull request, gets made. CI runs, passes or fails. It's like, and then a human like either fixes up the PR so that it actually passes, or merges it and it lands, and then the new package gets built and uploaded. And so a lot of this stuff, particularly when we did this large compiler migrations, like lots of it failed initially, because one does not simply substitute out all the things and change the way how compilation works. It turns out lots of packages, particularly in sort of academic sciencey packages, tend to assume that GCC is called GCC, the executable, and it turns out that's a problem when you're doing these like cross compilation, like multiple compiler things, and so
I'm feeling personally attacked coming from bioinformatics.
It's pretty standard, and it's like it's not a we've seen this happening often. So it's like, so a lot of it has also just been to like in these things to try and like find all the common patterns, and then just try and like, okay, here's how you fix all of them. And so like trying to this sort of codify this, it's like a human does the same fix all the time, and so just like getting a robot to do it is great.
Yeah.
But occasionally quite hard, because you've got to be a lot more precise.
So can you like explain like I'm5 kind of the logic behind that? Is there sort of a rules-based engine that kind of looks behind and tries to investigate the recipe for certain errors, or is it more of like a documentation kind of deal where you go and you look through the logs and then it says this failed, and then maybe there's like a regular expression that greps and says GCC failed, so go fix that in the recipe or something like that? How does that work?
Right now, our approach is mostly it's like go look at generally just look at the metadata for the recipe itself, and there were like a bunch of like relatively easy things that we could spot just from the structure of like what your dependencies were and how they are now. Everything's mostly been moved to like things that are current, that are sort of the current format for what a Conda recipe should look like in CondaForge now. There's still a bunch of things that never got migrated, but those packages are effectively abandoned at this point. And it's like we're sort of slowly working our way through and actively archiving those as it's clear that nothing's going to happen on these. And the original maintainers of those packages have either moved on, or the package is no longer relevant because like it hasn't been developed on anymore or whatever. It's like it turns out when you're at the point where your ecosystem gets very large, there's a bunch of dead branches on the tree, and that's fine. That's nothing weird. You just need to sort of like be somewhat cognizant of it. And so some of our sort of like future things that we were sort of like thinking about is potentially getting into the more sort of active remediation kind of thing, where we actively go look at logs and we find like common patterns and maybe just start suggesting things. That's sort of like some of the sort of like more future work that we're thinking about, but we're not quite there yet.
Yeah, for the most recent sort of big new platform, which is Apple Silicon, Isuru, who's another one of the core devs and helps with the bot, actually put in some very simple modifications to build.sh scripts. These are bash scripts that actually just run things like make or cmake that help that. Those packages are all cross-compiled. So he actually put in some modifications where the bot will automatically insert statements into those build.sh scripts to enable cross-compilation, and they mostly work. But build systems, in my experience anyways, are inherently very fragile. And so a lot of this stuff requires a human to just go look at it and make sure it gets done.
Yeah.
And these kind of migrations are good opportunities for us to also provide some metadata house cleaning or housekeeping. So like one of the things that we've done is try to like fix issues where we're missing licenses. And we kind of go through and have the bot populate those.
Yeah, by just looking at a bunch of stuff and doing some sort of lightweight, sort of simple pattern checking. It's like, hey, is there a copying.txt or a license.txt, or any of these sort of like standard things that look like a license? If it looks like a license, talks like a license, contains some magic text that definitely is present in licenses, it may very well be a license. And then sort of using those as suggestions.
Oh, that's what we should be doing. We should have a regex for the copyright symbol.
Good luck. Good luck on that one, CJ. Yeah, you can let that bot into the wild yourself.
Yeah.
But yeah, so I was pulling this up. The bot has issued almost 70,000 pull requests.
Wow. Did the bot get its Hacktoberfest t-shirt?
It has planted so many trees. No.
Yeah. In fact, like when the bot started, I believe it may have costed a lot of people their Hacktoberfest t-shirts, because initially they like one of the easiest ways that you could have gotten your Hacktoberfest t-shirt as a maintainer of a couple of Conda Forge packages is you just did a couple of version bumps, right? That you issued yourself by hand.
No, it's true. You Conda people did code me out of several jobs.
Yeah.
For real. Like that, it used to be a full-time job to just maintain software stacks on HPC systems because you would always have to compile everything from source every time. And now, and now the bots are doing it for me.
Yeah, some people still do that, and they hopefully will stop one day.
Yeah.
Yeah, I hope we all get to stop one day and move on to something else.
Like, hopefully, most of the people that are doing that are doing that because they really have to, and they're on like bizarre architectures, like HPC folks in particular.
Yeah, those things exist. They're just not common, so most people shouldn't be doing it.
It turns out like most people are running on relatively stock, x86, architectures, exactly. And it's like, it's fine.
Yeah,
we were fine. But it did. That's why I was asking you guys in the beginning, sort of, what was the evolution? Because when I first got started, it required so much buy-in from like all the HPC admins and the higher ups and everybody, and it was this big task to go and explain.
I think one of the other. Yeah, I think one of the big like success parts of like why Conda has worked, particularly in the sciences space, is because unlike most of these other things that you had to do on these big HPC systems, like Conda can run entirely in user space, and you don't require you don't require the admin of your HPC system to go install a bunch of stuff for you, and so you can just run your thing and it works. And that's sort of like that was the big reason why like this ecosystem has functioned, is like you can install packages and you don't require, and it doesn't require end users to have like a full compiler stack like configured fully.
Well, not only that, also they don't have to even know how to compile things.
Yeah.
Right? Your end user should not have to know how to compile literally anything. So, I mean, it's that aspect of it. But then, I mean, I really think it's the bots that keep it going, because it really did used to be a very, big job to kind of continually maintain these packages and bump them. And, people move on from the person who initially puts in the recipe, often moves on, and sometimes the recipe is relevant and sometimes it's not. But somebody has to maintain that, and now the bots do it.
Yeah.
So with that, Marius, so which bot are you taking responsibility for?
So the one I've been mostly working on is the more sort of this sort of large scale migration thing. So the thing that sort of like interested me is so initially when we did the migration stuff, we ran one migration. And so we ran the big giant migrate all the things thing where we migrated from this GCC version and these Python version, and that worked. And then it's like we said, it's like, well, this is useful. So how can we generalize this so that we can run multiple migrations concurrently? And so Conda has this thing called as part of Conda variant of Conda build called a variant. And there's a sort of a variant matrix that applies a bunch of like pinning constraints. And these sort of can be used to sort of fix certain versions to maintain ecosystem compatibility. So for example, we can say it's like, we're going to build everything with like GCC 9, and it's going to use a certain version of libxml, and like we've got a whole big list of this stuff. And so what we've sort of generalized this to is that whole big list of this stuff, there's actually an algebra that we've defined that you can sort of take little snippets and add them to this and get and generate a new sort of updated thing that contains like separate portions of this sort of big pinning constraint set. And so in doing so, we can run multiple migrations concurrently, and they don't need to necessarily be aware of each other, as long as the eventual consistent state of this thing sort of makes sense. And so we've gotten to this point now where it's like quite generally we're running it's like 10, 15 migrations concurrently, and for these packages that have constraints on them, we will actually start these migrations almost automatically, and sort of we can sort of do things where it's like there's a new Boost version out, and so you have to go recompile the entire world that depends on Boost, which we do every now and then because
we only ship every other Boost version. It's too much work to do all of them.
Boost is a lot of work, but for example, there's a new version of like Apache Arrow out, and you want like rebuild everything that depends on like the binary portions of Apache Arrow. We can sort of like automatically trigger those things, and and it'll just like go issue all of that. And then once those are done, they get sort of folded back into the mainline sort of constraints that you get by default. And using that sort of underlying system, that's now how we run all of our migrations. Initially, like they were all sort of like slightly hand-rolled, fairly special like classes that did their own individual tweaks, and now they all pretty much look exactly the same, which has been great on a sort of maintenance and stability and like understandability of like, what is this thing doing? Is doing a Python migration any different than doing a libxml migration? And the answer these days is actually not really. Python is still a little special, mostly because it's a dependency of Conda itself. So there's some consideration that has to happen for this, and also like the scale of say moving Python or R is much bigger because you have to rebuild thousands of packages versus the sort of more standard hundreds or tens.
That's a very impressive scale of work to be considering there. Man, Arrow is like my new dependency problem. They update so fast.
Arrow's moving quickly, and the thing is like Arrow is a bunch of binary stuff, and so you have to move that entire ecosystem like whenever a new Arrow release comes out, which is fine. Like Conda Forge is well suited to do that.
Yeah, works.
Well, thank you for doing all the hard work there. Like, I'm just thinking, like, the last time I really feel like I had packaging problems, like LXML was the one that always like bummed me out. This is a long time ago, right? So at this point, I'm just like, I don't have packaging problems because of all the hard work y'all are doing. So, but yeah. So I guess Matt, it's your turn to advocate for the last bot. Can you tell us a little bit about what this bot does, who it is, how it works?
Yeah, I'll play bot cleanup and just name through some others that we have that do minor things. So
Killer.
So the big other one besides the auto tick bot is our web services. These are the admin commands you run on a feedstock. So if you're typing at Conda Forge admin, please re-render, that's actually a Heroku app which listens to a GitHub webhook and pushes back out, changes to commits or changes to the feedstock by making a commit after re-rendering, things like that. So that bot's really important for our users day to day in order to just maintain their feedstocks. We don't have to do that much to it anymore, which is pretty good. We've put a lot of effort into it recently to make it more efficient. There's the auto merge bot, which I wrote. This goes hand in hand with the auto tick bot. So certain PRs, especially when we did the big R migration to R4.0, will have the PR be automatically merged if it passes. And so the maintainers of the R stack on Conda Forge agreed to this. So we added auto merge to the entire R stack. And then, once the auto tick bot issued the R4.0 PR, if it passed, it was automatically merged. And then the bot would just move on to the next package. So there was actually very little human intervention into that migration. And then there's the admin migrations bot, which is very confusingly named. That bot is used for key rotations. So we have some secret keys that we keep on feedstocks to allow them to do uploads, and we need to rotate those keys. So we do that every once in a while as well. So I think that's the rest of our bots. I can't think of any others that we have.
Yeah.
Stage recipes, you could call that.
Stage recipes is probably a bot at this point.
So.
Very interesting. Very interesting. So one of the things I'm curious about when I hear this is like you've abstracted this layer out where it's like, okay, we've got these bots and they do these things. How does the effort like kind of displace in the sense that like, you do a little bit of work on this bot and you save all of these human hours? Like does by focusing on the bots, like really, is there just a huge impact at scale in the way that y'all think about this?
Yeah, for sure. Conda Forge wouldn't work without the bots.
Yeah.
Like we maintain roughly 11,000 GitHub repos. So, if anything needs to be done to those repos, you can't do it by hand. And so it's table stakes at this point in Conda Forge.
Also, it's like given the way how you interact with the GitHub API, you can't even really do it by naively looping through the repo on the GitHub API, because it turns out GitHub has API limits, and you hit them if you're at sort of Conda Forge scale. And they're very easy to hit.
Yeah, it'll take about.
How are you doing this if you aren't? If you want to get a bit into sort of the backstory of the bot, how are you doing it if you aren't hitting the GitHub APIs?
Well, commits are free, so that's good. But
I love that bot, by the way. Like, I was so happy when I saw that was a thing, and I didn't have to install the Conda Forge re-render.
Yeah, that one's nice.
Yes.
Predates me, but I've done work on it. So in terms of the API limits, like the admin migrations bot, it just runs on a cron job and it just goes. So it'll take about probably about 12 hours if we have to make an API request for every feedstock, roughly. Depends on the number of feedstocks we have. But so things move slowly. And that also means that if you push a change and it breaks something, it can be quite a long time to recover. If you need to make a bunch of API requests.
Break something. Oh, that's very optimistic of you guys.
So
what's on the back end now? So is it GitHub Actions? Is it Travis? Like what eventually won out in sort of the war of the CI services? Because I know, they were really like going at each other for a while.
So most of our stuff is built on Azure pipelines. This is like we've got an association with Azure pipelines, and they generously donate a very large amount of build capacity to us. So we can run at a higher scale than most than your regular sort of free Azure pipelines thing. We also use a couple of other CI services. So we use Drone to do some of our ARM 64 stuff, and we use the weird Intel PowerPC, IBM PowerPC Travis CI things to do some of our PowerPC builds for like HPC systems that care about those.
This is actually, sorry.
Yeah, but we've and most of our sort of the bot side of things, like a lot of that tends to run on GitHub Actions now. They used to run fairly heavily on Circle CI, but we very recently switched all of that to run on GitHub Actions because we actually get like better scale and performance out of them.
CJ, you want to add something?
Yeah, so this is actually one of the interesting things that you can do with CondaForge is that you can actually run the CondaForge commands to provision the CI YAML files. So like if you didn't want to like have to decide among the CIs, you could just use CondaForge's infrastructure to build your CI scripts for you, which is a nice way to try to like abstract away from the like which CI do I choose. You could just say, well, we use whatever CondaForge is using at the moment.
Yeah, and so.
Yeah. Interestingly, we don't do that for our own CI services.
Yeah, we should fix that.
Well, the jobs are complicated because, a lot of the times, like especially for the bot, if you hit cancel in certain parts of the job, that might result in some data loss. And so you have to very carefully construct the jobs so that they, fail nicely. So you make sure you don't lose data, things like that. So that makes it a little harder.
Okay, so wait, so we're talking about two separate levels here, right? We have the CI to actually run the, let's say, Conda build, and then we also have the CI that takes care of the bots. Is there another, like, does it get more meta than that? Is there another layer in there, or is that it?
I mean, there is CI that runs the tests for the bot.
Okay.
Yes, in principle.
The answer is yes.
Yeah.
You can always go farther down that rabbit hole, huh? Okay, cool.
And that CI obviously installs packages that were built by CondaForge. So, it nicely self-reinforces.
I mean, the ecology of this community is beautiful, right? Like the way that everything uses everything. It's really interesting to hear.
Just wait until we make the package that has the mappings between the feedstock names, what Python imports they represent, and what PyPI packages they try to represent.
Yeah.
Is that a plan?
Package
Is that like a real plan that you guys have?
We have most of it.
Yeah.
Cool. So that's what's coming down the pipeline, huh?
Yeah. So as part of the process of making the particularly the updating and generation of Python recipes, which is still like the lion's share of what CondaForge ships. So Python recipes are sort of somewhat problematic in that due to historical reasons, there isn't particularly great metadata on like PyPI to know what the dependencies of a Python package are. Kind of have to install it to know. And so there's a bunch of stuff these days for trying to tease some of that out. But that gives you Python package names or Python import names. These are not necessarily the same as like, the Conda package name or like the apt package name if you install it with apt or any other packaging system. And so we've been working on a tool called DepFinder and Grayscale for generating sort of particularly sort of PyPI based Python packages, and so sort of working on those parts of the ecosystem gets us to a point where we can like build out a better mapper that knows that it's like the thing called Docker. It's like if you say pip install Docker, that is equivalent to saying conda install docker-py, right?
Or the other example is scikit-learn, right?
Yeah, scikit-learn
Install sklearn is not really a thing.
Yeah. And so getting to a point where we've got a fairly rich mapping of this. We mostly have that like ready, and so we're going to get to the point where we can, when we issue a version bump PR to a PyPI package, we can start inspecting that package and saying it's like, hey, the dependencies of this package have changed, and we can actually go pick up and correct and adjust the dependency set for your thing in the bot. Presently, that isn't done automatically, but it's pretty close to getting there.
Yeah, that works pretty experimental still. So we've just got a hint sitting in a text box saying like, hey, this is what the bot thinks your dependencies might be.
Yeah.
Because we think you're missing some, or you might have too many.
Yeah.
Maybe go look at that.
Yeah.
That's mostly just because.
Yeah. But as we move further, we can get to a point where we can run the thing with the stock. We can potentially run it after that with a changed set of dependencies and see if that still continues building. And so getting to the point where, so particularly on the Python side, sort of we're moving towards a world where we actually run a larger portion of the test suites of these packages, because like unfortunately the only way to really know if a Python package works is to actually run its test suite. The R ecosystem is a lot better with that because they mandate clean metadata, like as part of like if you upload a package to CRAN, it's like you give a metadata file that says like I depend on this stuff, and those are easy to parse, and so that's sort of the reason why we could turn on like automatic merging for the entire R ecosystem like pretty safely, and we want to get to a world where we can do the same for the Python ecosystem.
Well, it's been killer hovering in the atmosphere with y'all and like getting this crazy top-down look at everything that's been happening. One of the things that I'd love to do, if we still can, CJ, is kind of get a visual look at how big Conda Forge is. And I know this is an arbitrary question, right? So let's treat this as like a fun thing. And like each of y'all can kind of talk about how big Conda Forge is from some perspective. And CJ said he had some visualizations that I'm going to let him get queued up. So Matt, what if you were to kick it off? How would you like us to think, one way to think about how big Conda Forge is?
I think the number of people involved, it's well over 2,000 at this point that are, members of the Conda Forge organization. And, they do an amazing job of maintaining the feedstocks. And there's a pretty large core team at this point. If you include Emeritus, I think it's 27 or 28 people now. And so the sort of human scale of Conda Forge is pretty amazing.
Yeah. So I have here the number of feedstocks we have over time, give or take a little bit. So you can see that we're pretty close to 11,000, 12,000. So that's just the feedstocks. Let's see if I can. So this is actually the number of artifacts that we have. So these are the individual packages that are built out for particular architectures or Python versions, for instance. I think we recently got to, 1.8 terabytes?
Yep.
Worth of Conda packages?
That's an enormous number. So we're looking at, go ahead, Jillian.
Oh, sorry, I was just asking, where are those hosted? Like the 1.8, that physical data, where is that? Is that also on Azure, or is that someplace else?
That's hosted by Anaconda Inc.
Okay, yeah, that's right.
Yeah, they're very generous, and they give us lots of hosting. Yeah, we've started to push it to GitHub releases now, so a portion of it's there. Anthony Skopaz keeps his own backup, and we're working with people in Europe to start hosting a portion of it there. So,
yeah,
very cool. So, Marius, I don't know, what would your take on the size of Conda Forge be? I
think the take on the size of Conda Forge is in my view has mostly been on the number of pull requests in across like all the Conda Forge like repositories, and that's like that has exceeded 100,000 like in aggregate like a while ago. Like more, I believe more than half of that is made by the bot these days. But like sort of general community involvement in that has been like consistent and growing. The most interesting thing for me about looking at these kind of forged graphs has generally been that, particularly on the number of packages, is how surprisingly linear it is. Just like the intuition is that everything's always exponential, but it turns out that those lines are pretty straight, which has always struck me as like the strangest graph.
It's super useful to keep a few numbers around. So we're adding about 3,000 GitHub repos a year.
Yeah,
those are new feedstocks.
Yeah.
So if you talk to us this time next year, we'll be from 11,000 to something like 14,000 GitHub repos, and that happened in 2019. It will happen in 2020 as well.
Yeah.
The other thing is that Conda Forge is at over 100 million downloads a month now of our packages from anaconda.org. So it's a big amount of data, and people are pulling it a lot off the web.
Yeah, I think since we've started keeping track of the downloads per month, like the integral of this curve is something like 1 or 2 billion packages, I think.
Yeah, it gets pretty big quickly now. So the side that we've seen is like, whilst the ecosystem has been growing linearly, the user base has been growing substantially larger than that. It's like as is clear by the number of downloads.
And even as like new feedstocks are added linearly with these kind of migrations and rebuilds, the artifacts is like sub-exponential.
Yeah.
Especially as we start adding for like Python, PyPy, and other like Python dialects.
Yeah. Over time, we've sort of expanded the size of our build matrix a little bit. It's like we still try and like keep it relatively small to not completely overwhelm our CI services. But like we do have, like, we used to build like 2 Python versions like way back. It's like when it started, and like we're now at like what, 5? Yeah.
At least, yeah.
Yeah. If you include PyPy, I think it's 5.
If you include PyPy, then it's like we built 5. Our Python matrix is like 5 versions of Python.
Yeah. Hopefully
As a
that'll go
reference.
back down, but we
Yeah.
have to wait.
This graph, which is slowly expanding, because my browser's slow to respond, it with some caveats is the number of builds per day that we run on Azure pipelines. And this is actually some work that Matt had done to go and collect this data. And you can see here this spike in October where we got to almost 14,000 builds in a day. And that was, I think, when we started issuing Python rebuilds. As we get through the first few packages, because everything ends up depending on certify.
Yeah.
As you'd kind of expect.
Yeah. Once you get sort of like past, you've now built pip.
Right.
Then suddenly the Python matrix expands. The Python graph expands massively, and you can start building like thousands of packages at the same time.
Yeah, I think that this May spike was when we rebuilt R.
Temporarily, that sounds about the right point in time.
I don't remember. It's been a little long.
Yeah, it was easily a 1,000 migrations ago. Like,
Yeah.
Well, it's clear that no, this is not a human feat alone. So thank you so much for sharing all of these numbers and metrics and progress. It's really impressive to see that, what, 10 to the 8 builds at some point there, or pack. I don't even know. The numbers are so big. It's very impressive. So let's start to wind down a little bit. What are some of the things that y'all are looking forward to in the future? Are there some places where folks can get involved in the community, help y'all out? If anybody wants to jump in on that.
So personally, I'm looking forward to more inspection. We're starting to do some more work on it, doing inspection of the underlying source code and the additional metadata that we receive, to try to hone in on dependencies and APIs. And that's really exciting for me. And that's some active work that we're doing.
Very cool. Very cool. Well, excellent. We look forward to seeing all the things that y'all have done, and maybe now's a good time to say goodbye. But I really want to thank everybody for being on this workshop. Jillian, I'm super happy that we got to meet each other today, and we got to do this together. I hope you had a good time.
I did. Thank you. It was really cool coming and getting to hear and see, just see how much the ecosystem has grown over the last few years and how it's really become, kind of much larger than the sum of its parts, I guess. It's very big and very cool. And I'm sure it'll keep growing, and there will be new bots, right?
Yeah.
Oh,
There will
I
always
hope
be
not.
new bots.
Well, hey, thank you all for your time, and thank you all for the hard work that you put in, making sure that we can do our science every day. We really appreciate you all, and we'll see everybody on a future workshop. I'm gonna just end the stream now, and